Hi everybody, this is the next stage in the Bachmann Voyager upgrade to DCC. In this video I'm going to show you how I convert a circuit board to work under DCC for the directional lights. I started off to remove the body. There are 3 screw points. Now, I hope my camera will pick up on this. There's one there behind this bogie, there's another one behind the bogie there, and there's one on the front here, right in the front, in the middle of the bogie, which holds this, so I don't know, sort of valance on. And once you've undone those 3 screws, the body just clips off in a normal manner, which is very easy. It unclips very easily if you use a thin card, or I use these, which are quite nice to slide in, and then the body just simply pops off. To connect the body to the chassis is via this 2-pin plug, which you can see there. Directional lights there connect to the pickups via this point here. So once you've just unclipped it, just move that out of the way for now, and remove the lighting unit, which just again unclips. Normally has a screw down the bottom, a tiny screw. Should be, it's right down there, but this one's missing on this particular one. Not too sure why, whether or not it couldn't be bothered. But anyway, the directional lighting circuit board. First thing you have to do is remove these 2 diodes, because they're not required on this occasion. The 2 methods I normally use to remove not just diodes, but any dead lights, LEDs or resistors that are soldered in. The 2 methods I use, I mean, you could just simply snip them off, but that would leave small legs, which it's not very good. The 2 methods I normally use to remove solder is, and I'll try and zoom in on this for now, in this part, is, let me zoom in a little bit, is I use this gauze, and what this does is soaks up solder. So what you do is hold the gauze up against the solder, apply your soldering iron, and as it heats up and melts, the gauze soaks it up, which is quite neat the way it does it. I've used quite a bit of this stuff when I desolder points, get the backing shot, or I use one of these. Zoom out a little bit. Oops, wrong way. I use one of these, and what this does is sucks up solder, and you prime it by just simply pressing this down. Let's zoom out a bit more. By pressing this down, release it again, this plunger, and it's just a spring action inside, and it creates a little vacuum. When you press this button, it sucks up wherever, and what you do is hold this over your solder point, apply your soldering iron, and as it melts, you just press the black button and it sucks it up, and then you just empty this when it's full, but I empty it all the time. So that's it for now, this part of the video. The next part I'll show you these things desoldered, and where and how I solder the decoder wires onto. So that's it for now. Be back soon. Hi again. Right, the next stage in the conversion of DC Voyager to DCC and the directional lights. What you have here is these 2 wires, as shown earlier, come from the pickups via this point here, connected to this 2-pin socket. Get back in shot. The wires then go, the connections then go to the top light here, which is, getting shot, that one there, and the other wires underneath, let's turn it over, are the directional lights, the white and the red lights. What you have to do is you have to cut across, hopefully that should be in shot, cut across here to separate this side from this side, because the decoder is going to sit between the power in and the power out to the lights. So as with DC, it's connected as one, and the polarity is reversed when the train is going in the opposite direction. But because we're doing DCC, the decoder is handling that transfer of positive and negative, so on. So what I need to do now is I need to solder on the black and the red from, let me show you the decoder. I'm using the same decoder as in the powered car, the Gauge Master DCC decoder. On this occasion I decided to cut the wire rather than, I've got a seat in a socket there, but I decided not to bother with all this wiring from the pickups, and cut this wire and solder the wires onto this unit, which I'll show you in a minute. I'll be using the blue wire, the white wire, the yellow wire, the black wire and the red wire. The black and red will be for the power from the pickups. The yellow wire will be for the rear red lights. The white wire will be for the front directional lights, and the blue wire is the common return. The blue wire will solder to this point here. Can we get that in shot? Move that over to this point there. Looking at my viewfinder, it seems to have been reversed. So it's that one. The blue wire goes there, white there, and the yellow there. Now the only difference between this and the other drive unit is, where's the white wire go there and the yellow there, you just yellow there and white there. That's the only difference between the two. So you get the directional lights, so it's red at one end and white at the other. So I'll solder those wires on now, and I'll show you them finished, soldered in position. You can see I decided to desolder the diodes rather than snip them off. The ones that were difficult to get to, I used the gauze to soak up the solder when it was melted. The other one I used that plunger type thing I showed you. So yeah, these 2 points here are the power in from the decoder. That's from the pickups, and so the power comes up here from the pickups through there into the decoder, back out the decoder to the lights. Blue wire here, yellow wire there, white wire there, and reverse on the other end. And that's it. It's as simple as that. So I'll solder these together and I'll show you, and then I'll show you, hopefully, it working. So bye for now. Hi again. I've now soldered the wires onto this small circuit board, where I've got blue here, white next to it. Hopefully you should be able to see that. Let's move this out of the way. And hopefully you should be able to see the blue and white there. Red and black which are connecting to the pickups, and as mentioned, the power comes up from the pickups through here and to the decoder, which is connected here, and the yellow wire here. And again, the only difference between the other unit is the white wire would be here and the yellow wire there. This, by the way, let's get in shot. It's the orange and grey wire. There may be difference on your decoder. Sometimes the grey is pink. Now that's got a 1K resistor. Now because they would normally go to a motor, and in the dummy cars there isn't one, when you come to program your decoder, many times you can get that decoder cannot be read from the controller. The controller says no decoder found or something similar to that, because there's no resistance on the grey and orange wires. So if you put a resistor in between the orange and grey, it can simulate being connected to a motor because there's a resistance. And I've done this once before, and I was able to read and write to the decoder, whereas before I couldn't. So what I'm going to do now is put all this back into the body and connect it up, and I'll hopefully show you it working. So that's the end of this part. As with any part of this, if you need anything specific explaining, please let me know. So it's bye for now. Hi again. I've now connected the unit up to the chassis, and it's on a test track, a programming track. So I'll turn the lights on now, and I'll do the reverse. You see the reverse just come on. The reverse one seemed duller. I'm sure it's like when I put it back in the body. So you can see that works really well. And so I'll just go to do the other one, turn the lights off, and put it all together. Now when you put them in the drive unit, let me get this in shot. When you put them in, stop now, in the unit, and before you screw the body down or even put it on fully, test it with the powered car connected to it, so you know that in the direction of travel from the powered car you're getting the relevant light. If you find it's wrong, it's opposite, I'm not too sure you can just, because the powered car is symmetrical, I'm not too sure you can just turn it around. Should you not, all you need to do is unplug this and turn them over, turn the wire over. So the black would go to the red, and the red would go to the black, and then that will change those. I hope that makes sense. So what I'll do, I'll put all this together, and I'll test it with the powered car, and I'll let you know how we get on. So speak to you soon. Bye for now. Hi, this is the final part of the conversion to DCC and directional lights. I haven't screwed it back on, but I just put it back on. I won't screw it until I've tested the lights are going in the right direction. The only issue I've found is that the lights are dim compared to when it ran under DC. But I do know there's a CV value that will increase the brightness or decrease. But in this case, I need to increase it. The red's not bad; it's the white that seems to be dim. Apart from that, it works really well. So what I'll do now is I'll connect the powered car up to it, and I'll see if the lights come on in the right direction. If not, I'll just swap those two wires that we got to plug together, just swap the wires over. I'll do that. So that's it. Hi again. This is a sort of amendment or an add-on or insert to this video. I wasn't happy with the white lights on the this unit. The red lights were okay, but the top white light and the headlights on the bottom, very dim. So what I did is I bypassed the circuit board completely. Let's try and show you. Turn it over. You might be able to see that. Where I got all the blue wires together, soldered them together, and then the white and the red on their own. Sorry, white and yellow, not white and red. And thinking it's going to be that. Let's tighten this a bit. It's going to be that's causing the problem. So I stripped it all out. I took away the circuit board that you saw here. That was transmitting the power from the track through to this unit. So I took that out and I put in a harness, an 8-pin harness, which you can see there. And I put in another decoder, because the first decoder had hardwired, and it was still the same. Because the only other thing I could think of, that there was a resistor somewhere, but there isn't. I couldn't understand why the white lights were low. I looked through the manual for the decoder, which is DCC26, a gauge master. I'm sure it's the DC620. Yeah, DCC26 OPTI decoder. Now the manual I downloaded from Gauge Master, it was comprehensive, but I couldn't find anything to do with get in shot with the lights. If anybody knows which CV to alter or why, the red light was fine. The light that controlled the red light was fine, but as mentioned, the white lights were very, very dim, as if they were receiving no power. I first thought the other decoder was faulty. Now I've either got a batch of faulty decoders, or there's a CV that controls the brightness somewhere, because it's not typical of say the white or yellow. The white or yellow. I swapped them over and it was still the same. So the current, you don't think it didn't test it, the current it was receiving, but it was irrelevant, because it didn't matter which wire I used, whether it was white or yellow. It's the top light and the bottom headlight were very, very dim. What I did is I went to Hornby and I bought their full function decoder, and let me try it. Probably won't work now. I'm running the JMRI software via the Sprog, and I tried it. Would you believe it? Perfect. Change direction. Come on. See? Perfect. So I'm very pleased with that. So the Hornby decoder worked perfect, but the Gauge Master DCC26 is not. Now, as mentioned, I tried two decoders and they both gave the same results. I swapped the white and the yellow over and it was still the same. So the voltage to the lights were okay. I stripped out this board, put in a harness, bypassed the circuit board, and it was still the same. So I'm assuming there's a CV on the on this decoder. So if anybody knows these decoders, and knows which CV controls the white and yellow lights, please let me know. So that's hopefully the end of this now. Thanks a lot.